Like I said in the previous lesson, an exponential function is a function that has a variable in the exponents. Okay. And you've seen exponential functions, you just didn't know that they were exponential functions. And when we draw this graph here, these two graphs, one of them will pop out as like, hey, I've seen that before in science class. So this is the general formula, y is equal to ab to the x. A cannot equal 0. Why can't a equal 0? What would happen if a was 0? Everything would be 0, right? It would just be 0 all, it'd be a horizontal line on the x-axis. So a can't be 0. B must be positive, greater than 0. Okay. B has to be a positive number. If it's not a positive number, you can have functions where it's not, but it's not an exponential, and you get weird things happening. And we can talk about that more if we take calculus. Okay, so we'll talk briefly about that. And b cannot be 1. Why can b not be 1? Well, for an exponential. What if b was 1? What's 1 to the power of 1? 1. What's 1 to the power of 2? What's 1 to the power of 3? It's always going to be 1 times whatever a is. So it would be a constant function as well. Okay, it'd be a horizontal line. And x can be all real numbers. They can be positive, they can be negative, they can be fractions, they can be whatever. Okay. All right. So we're going to look at y is equal to 2 to the power of x and y is equal to 1/2 power of x. So I don't usually do tables, but we'll just do them briefly for this. 2 to the power of x. So that's essentially saying 2 to the negative 3, because this is our x value is negative 3. What's 2 to the negative 3? What does the negative 3 do? Flips it. What's 1 over 2 cubed? What's 2 cubed? So what's 2 to the negative 3 is 1/8. What's 2 to the negative 2? 1/4, because it's 1 over 2 squared, so it'd be a fourth. What's 2 to the negative 1? Not 2. Close. 2 to the negative 1 is 1/2, right? You just flip it. What's 2 to the 0? 1. Anything to the 0 power is 1. What's 2 to the 1? 2. 2 to the 2? 4. 2 to the 3? 2 to the 4? Okay. So let's plot those. Now the 1/8, 1/4, 1/2, just make little tiny dots. Who cares? It's the other stuff after. So I'm just going to start with 0 and 1. 1 and 2. 2 and 4. 3 and 8. And then 4 and 16 to be off the page. And the other ones are really small. So that is 2 to the power of x. Okay. Let's do 1/2 to the power of x. So 1/2 to the negative 3. What does the negative do to the fraction? Flips it. So really that's 2 to the power of 3, which is 8. Okay, what's 1/2 to the power of negative 2? 4. 1/2 to the power of negative 1. You seeing a pattern here, peoples? What are we going down by? We're dividing by 2, right? So if I divide the next one to the 0, it's always 1, and 2 divided by 2 is 1, so that works out. What's 1/2 to the power of 1? 1/2. What's the next number? And 1/16, right? So if we plot those points, -3 and 8, -2 and 4, -1 and 2, 0 and 1, and then they get small on the other side. So that orange graph is 1/2 to the power of x. What does the orange graph remind you of? Something you've seen in science. Graph that goes like this. Radioactive decay. You guys taking physics 11? I think you're doing chemistry 11. Science 9 or 10, you got to do it. Half-life graphs? Has anybody seen a half-life graph? You know, like if you have 10 grams of a radioactive substance and then it has a half-life of 5 minutes, let's say. 5 minutes later, you have 5 grams. And then 5 minutes later, you have 2.5 grams. And then 5 minutes later, you have 1.25. It keeps cutting in half. Hence the name half-life. Yeah? Called a half-life not only because it cuts it in half. You've never done that before? Okay. It's called a half-life graph also because it's the base. 1/2. That's why it gets cut in half. Anyway, we're going to look at word problems later on, so we'll deal with it then. Okay. So these are both exponential graphs. This one is going up. Would you call that a growth or a decay graph? A growth graph. If it's going down, you would call it a decay. See, now we're talking. It's more fun when you talk than the idiot up here talking. Let's look at this. Do you see any sort of symmetry in these graphs between the two of them? You got to explain that. You can't see it. Don't look at. Okay. Okay. What is it then? Just in any sort of words. What is the symmetry? How are they related? Reflection. Boom. Boom. Everyone see that? It's just a reflection. Here's why. Don't write this down. We'll talk about this later. But if I took 1/2 to the power of x, now I didn't want a fraction, okay? And I wrote it as 2 to the power of -x. Is that the same thing? Yes, right? That negative is in front of the x. Thinking back to the unit, the test you just wrote. What letter is that in that big long A, B, F, B, H, X minus H, A thing? B, which does, and if it's negative, it's a reflip over the y-axis. It's all related. All right. Okay. That was my little weird rant. You guys heard of the word asymptote before? Okay. An asymptote, this funky word right here, basically is where you can't touch it. There's vertical and there's horizontal. Horizontal, obviously, other than me screwing up vertical and horizontal last week, horizontal is this way. Okay, vertical this way. No verticals here. Horizontal is this x-axis here, because that is when y is 0. So if you think about it, is there any number I can put into either this x or this x that will make the value of the function 0? for the way these two particular functions? There isn't. Because if I put 0 in there, anything to the 0 power is 1. Okay? So the horizontal asymptote of these two is y is equal to 0. This line right here. Okay? It doesn't touch the x-axis. It gets really, really, really close, but it never ever touches it. If you took this graph, you can see it's getting closer and closer. It's 1/2 to the power of x. I could put whatever number you want, 100 in there. Is that a really big or a really small number? It's really small, right? Because it's like 1/2 to the power of 100, which is like 1 over big, right? Which means it's actually a really small number. You never ever touch that graph, that axis. Okay, let's fill out this. What is the domain of both functions? In other words, are there any restrictions? So what did I say you have restrictions when you have what? What two things? Give me one. Can't divide by 0, so we have a variable in the denominator. Do we have a variable in the denominator for either one of these? No. What was the other one? Negative. Do we have a radical or square root in this? We don't, right? So are there any restrictions? So what is the domain? All real numbers. And you can look at the graph and you can see it just goes on forever. Okay? So I'm just going to write x here. Okay, the range of this function. What is the lowest value possible? Who wants to say 0? I just said, can you touch 0? No, but you can get really, really close. So what am I going to write for the range? Just above 0 is the range. Okay. Essentially, you're right. But it goes up to infinity, right? So we're just going to write, yes, greater than 0, but not equal to 0. So just greater than 0. No little liney thing underneath. X-intercept. None. Whoever said that. You said, Danielle said it, and somebody else said it. There is no x-intercept, right? Because I said it never touches this axis. So, nope. Y-intercept. Where does it hit the y-axis? 0, 1. I like that you gave me the point. Most people just say 1. All right. Equation of the asymptote, i.e., asymptote is what? Just define an asymptote for me. It's the line it can't touch. Okay. What line can't it touch? Yeah, it's the x-axis, but it's what when y is 0. So we say the equation of the asymptote is y equals 0. And we just talked about this earlier. 2 to the x is growth or decay. Does it go up or down? Growth. And this one is decay. Okay. There's going to be a lot of, first bit here is just a lot of theory, which is me talking, so I apologize for that. Okay, next bit. I think we can do this without actually graphing points. We can kind of do it intuitively. So 3 to the power of x, 10 to the power of x, 1/3, 1/10. Of these 4 functions, which ones are growth, which ones are decay? So just tell me. Fill it out. Which ones are growth? The first 2, these are growth. How do you know? Sorry? The base is not a fraction. Okay. If the base is a fraction, it's a decay graph. So these are decay. Okay. Which one do you think rises faster? Three to the power of 2 is what? 3 squared is 9. 10 squared is 100. Which one rises faster? All right. The bigger the base, the faster it rises. That's all you have to remember. Okay. And we should do this. Y-intercept. How do you find the y-intercept of anything? What is the value of x? 0. If I put 0 into either one of these graphs, well, to all these graphs, what do I get? 1, because they're all some number to the power of 0, which is always 1. So it's 1, 1, 1, 1. So they all go through this point. So if I was going to sketch them, and you know me, very just generalized sketches, what line can you not touch? X-axis, y is equal to 0, right? So we can't touch this. So usually with a horizontal asymptote, you represent it with a dotted line. So that's our horizontal asymptote. Can't touch it. And if I'm going to sketch 3 to the x and 10 to the x, 3 to the x, I'll just go like this. It's growth. So it goes like that. There's 3 to the power of x. 10 to the power of x rises faster. So the small numbers kind of stay the same. Goes through the same point, but then it takes off and rises faster like that. What about 1/3 x and 1/10 x? Which one falls faster? 1/10. And that's just because they're reflections, right, across. So if you look at, and they all go through this. So this would be 1/10 x and be 1/3 x. Okay. You need to know which ones, how to determine if it's growth or decay. Growth base is greater than, well, it's not a fraction, it's greater than 1 essentially. And if it's a decay graph, the base is less than 1. Going once, going twice, are we good? Skipping all that. Okay. So let's sketch the graph of 3 to the power of x. Growth or decay? Growth. These are all growth, right? Because look at the base. It's 3x, 3x, 3, or it's 3 to the power of x. So they're all growth. Let's do the y-intercept. Remember, that's when x is 0. So for the first one, just say all growth. 3 to the power of x. If I put a 0 in for x, I get 1. So the graph looks like that. It's a really bad graph, but it works. Okay. For the next one, 2 times 3 to the power of x. Now, first of all, do not do this. What I'm about to write, I'm not going to write on this computer screen. I'm going to write on the board. On the computer screen so that you can, if you look at the video. Do not do this. Okay? Why can you not do that? They don't have the same base, exactly. Okay? Do not do that. Please, 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 no. Okay? It is not 6 to the power of x. It's 2 times 3 to the power of x. All right? I'm going to erase that because it hurts my mind to see it. Please don't do that. All right. So what is the y-intercept of this graph? So I put 0 in for x. That means I'm going to get 2 times 3 to the power of 0. Ooh, I love that. So it's right there. Is it growth or decay? Can you tell me the other two y-intercepts? 5 and 0.5, right? Do the exact same thing. Five, 2, 3, 4, 5. And then 0.5. Does that remind you of anything we did last chapter? I.e. yesterday. If you just look at this, what letter is that? What did A do in that big long AFB? Starts to vertically. Does the same thing. Right? It takes our base graph, 3 to the power of x, and if I put a 2, multiply the y values by 2, or you multiply them all by 5, or you multiply them all by 0.5. It's the exact same thing. Okay? So, we can quickly fill out this table. The base b in all of them is 3 for all these functions. The a value is in the first one 1 because they don't have anything written there. In the second one 2, 5, 0. Y-intercept, whatever the a value is. Okay, so in this case it'll be 1, 2, 5, and then 0. Okay. So it's a vertical stretch, right? Is that okay? All right. You want your break now, or do you want me to finish this lesson and then go on break? We only have a little bit more left. Finish the lesson, that's what I want to do. All right. Last bit. We'll do that tomorrow. We'll do this right now. Okay. I'm going to ask you to sketch or know how to recognize exponential graphs. Okay. First of all, if you have a variable in the exponent, you know it's exponential graph. And then I'm going to give you a bunch of transformations to do on it. So we've gone from this 4 to the power of x to this. Okay. So we're going to describe what happens. What is the 2? What letter? A is equal to 2. What does that do? Vertical stretch by 2. What is this number? What letter is that in this equation? Yes, it's h. Right? Because it's tied up with the x value. So that is your h. All right, h is 2. What did that do? Moves it right 2. Okay, we're going to sketch this, even though it can be tricky. So when I'm asking you to sketch a vertical or an exponential graph, all I'm going to look for is horizontal asymptote, y-intercept, and if it's growth or decay. You get those 3 things right, you'll get the graph. I'll give you 4 more. Okay? So, first of all, y-intercept. Okay? Now you can't just blindly go 2 because we've moved it. So you got to do a bit of math here. So y-intercept. What's the value of x at the y-intercept? 0. So you plug in 0 into your equation. So I get 2 times 4 to the 0 minus 2. 0 minus 2. Negative 2. So I get 2 times 4 to the negative 2. What's 4 to the negative 2? 1 over 4 to the power of 2. What's 4 squared? 16. So it becomes 2 over 16, which is an 8. All I need you to do when you're going to sketch this is mark your x-intercept and just put a 1/8 there. Then I will ask you, does the graph rise or fall? Is it growth or decay? How do you know it's growth? The base is bigger than 1. So then all you got to do is this. Horizontal asymptote is at 0. So if you just go y is equal to 0, walk away, you got 1/8, it's growth. Okay? All right, last one. We went from y is equal to 2 to the power of x to y plus 4 is equal to negative 2 to the x over 3. All right. What's wrong with the way this is written on the right side, the y plus 4 thing? You want to move the 4 over, right? So we're going to go y is equal to negative 2 x minus 3 minus 4. Okay, and this is a total teacher thing. What is your base? Is that 5? Wow, sorry. There you go. What's my base? 2. It is not negative 2. Okay? Because the base can't be negative. All right? Remember, we defined that right at the... Where is it? Right here. Base must be positive, okay? Cannot be negative. That's just part of the definition. You know what? I'm just going to show you why it can't be negative right now because it'll clear up. So if it's negative, if you have negative, I'll just say negative 1. Negative 2. And I put 2 into it. All right? What do I get? Positive 4. So 2, I get positive 4. And then I put 3. X is equal to 3. What do I get? Negative 8, right? And then I put 4 in. What am I going to get? Positive 16. So what happens is the graph jumps back and forth like this. All right? So it's not an exponential graph, right? Because this will alternate positive and negative depending on what the exponent is. And if you want, if you're really into graphs, look up the popcorn graph on Desmos or in Wikipedia. It's just a bunch of dots and stuff. Anyway, back to this. So my base is 2. B is equal to 2. Doesn't do anything because it's the same as the original. What's my A value? Negative 1. And I'm not going to write B is equal to 2. We should write the base is equal to 2. Sorry. It's going to get confusing here in a sec. So let's write base equals 2. All right, so A is negative 1. So that's telling us we've done what? flipped it over the x-axis. So we're going to do this. We're going to draw it after the end of this. Okay. What is this for? -4. That's k. -4. So we went down 4. Down 4. This is flip over x. We're not going to do this bottom one here, so we can go into that space if you need to. So flip over the x. Okay. This is why I didn't want to write b is equal to 2. What is my b value in terms of transformation? Okay, so look at this function, x. And remember, the b value is in front of the x. It's being multiplied by the x. How did this x change here? What did I multiply by? X over 5 is same as 1/5 x. So it's my b value. 1/5, right? So b is 1/5, which means what? We wrote a test on this yesterday. If b is 1/5, that means you're doing a s, hs by 5. Okay. All right, so when you're sketching these graphs, what am I looking for? Intercept, growth or decay, so does it go up or does it go down? And there's one other thing. That could be a lot of different things. Asymptote, okay? Those are the 3 things I'm looking for. So, x-intercept, we can do that. We're gonna do it in this part here. So, x-intercept, not x-intercept, y-intercept is when x is 0. So if I put x is equal to 0 into this, I get y is equal to -2 to the power of 0 over 5 minus 4. 0 divided by anything is what? 0. 2 to the power of 0 is, there's a negative in front of here, so that becomes -1. What's -1 minus 4? -5, right? So our x-intercept is -5, or y-intercept, why do you call it x-intercept? -5. Okay. Is this a growth or decay? Growth, right? However, what have we done? We flipped over the x, right? So if you think about it, if you actually sketched out the transformations, and I said, took that negative away, it's gonna look something like that, right? I don't know why I'm covering it up with the computer screen, because you guys can't see me doing that. If I took that negative away and just had 2 to the power blah, 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 that's gonna be a growth. The negative causes it to go like that, right? So then it's going like that. Does that make sense? Okay, so, and we know it has to go through -5. So it's gonna go like that. So now you've got the growth decay part, you've got the y-intercept part. The only part that's left is the what? The asymptote. Okay. So that is the line you can't touch. Here's the thing, the asymptote will move with the up-down shift. So if my regular asymptote is at 0, and this moves the graph 4 units down, it moves 4 units down. So where's my new asymptote? -4. So you just draw a dashed line, -4. And that's your sketch. That's all, I know that's all you need, but I want you to be comfortable doing that. That's taking a bit of what we did last chapter and adding it onto this. It's break right now. Go for break. Grab something, go to the washroom. or past break actually, but whatever. And we'll do some questions when we get back.